Hello, my amazing chemistry students. Okay, so actually, before I turn to this page, first thing, make sure you pull out your Unit 7 packets. If you were not here the day that we got these, because I know they're pretty new, they are either on the counter where we normally pick up stuff, or I've put them on one of the back tables. So if that's you, go and grab the Unit 7 packet, okay, because everyone needs a Unit 7 packet. And we're in our groups right now, and I want you to look around at your group. And first thing, if you are a group of 4, then I want you to separate into partners, okay? You decide, I don't care, but we're working with our partners instead of a big group of 4. If there's only 3 people at your station, then we're gonna be a group of 3. And then 2 of you, obviously you're good, you're a partnership. If you are the only person in your group, then I want you to go ahead, get up and find an empty desk and join another group. And so everyone today, we need to be working with either partners or groups of 3, okay? So we can pause the video for a minute if we need to get that all sorted out, but figure out who you are working with, partners and groups of 3. Okay, so now we got our partners and our groups of 3. We're going to be doing an activity that ties to what we discussed last class. So we had a reminder about when molecules are polar or non-polar, and we were drawing those Lewis dot structures. We were remembering the 3D shapes, and that's going to be really important. So I just need you guys to know that molecule polarity is the primary contributing factor to IMF's intermolecular forces. Okay? So turn to page 7. All right, so everyone, we are on page 7. And on page 7, we are asked to draw the Lewis dot structure for water below. Okay? Now, each partnership needs to grab one of these kits. Okay, so if you haven't done that, and actually let's do that now. So you have your partner, right? And I want you to pause. I have a box and I will label it like IMF model kits, okay? And it'll either be at the front of the room or it'll be on the counter where you pick stuff up. And each partnership or group of 3 needs one of these Ziploc bags. Inside the Ziploc bags, there's a bunch of water molecules. Okay, so a bunch of water molecules. And then you have another little model in here, and there's a green one that's bigger and a blue one that's smaller, and we'll talk about that in a minute. And so pause the video, everyone go grab one of these, one per group, per partnership, or group of 3. Okay, pause, do that, bring it back, great. Now, we are looking at this water molecule, and we need to draw the Lewis dot structure for water. Okay? And we've been practicing this, so just a reminder, we got H2O. So I'm going to put oxygen in the middle, and it's going to be bonded to the hydrogens. Hydrogens each brought 1 valence electron. And so they're good. Like, they brought the 1, and we have accounted for that 1. Oxygen is in group 16, so it has 6 valence electrons, and we've only drawn 2 of the 6. So we're going to draw the rest of them. So 1, 2, 3, 4, 5, 6. And this is great because then we don't have to do double or triple bonds. But what's so interesting, though, is 2D, how I have this drawn right here, it looks symmetrical. But we know that 3D, it's not actually symmetrical. We have how many domains? 1, 2, 3, 4 domains. Okay, you don't have these model kits today, but this is going to be really important for water. And so let's just remind ourselves like what we know about water molecules. So I'm grabbing that 3D shape kit right now. Two of our 4 domains are the hydrogens. okay? But then there's also lone pairs. These ones are up here. So look, it's not linear, right? It's a bent molecule. The electron geometry, if we think about all 4 of the domains, it's tetrahedral. But then if we ignore the lone pairs, it's not linear, it's bent. So I want to think about that 3D shape, okay? So I'm going to draw that because it says determine and draw the 3D shape, okay? This is what's in the plane of the paper. Okay, so that's what's in the plane of the paper. I have a lone pair that's coming out of the paper towards us. So that would be a solid wedge, lone pair. And then I have another lone pair that's going into the paper away from us. Okay, so that's going to be a dashed wedge. Okay. So determine and draw the 3D shape. The electron geometry is tetrahedral. The molecular shape is bent. Is water a polar or nonpolar molecule? Everyone, this is asymmetry, asymmetrical. Okay? The hydrogens are not directly across from each other. It doesn't look like this in 3D. And so we get this asymmetry, and asymmetrical molecules are polar molecules. Okay, so like this is a polar molecule. Okay. So if polar, include polar bonds, partial charges, and draw bond dipoles. Okay, let's do the dipoles and just remember what they mean, because that's going to be important. So when we subtract the electronegativity, so oxygen has an electronegativity of 3.44, and we subtract that from hydrogen's electronegativity, 2.20, okay? We get 1.24. And I've left the range up on the board. It's still drawn there. And we know that if we subtract them and it falls between 0.4 and 1.7, that this is a polar bond. And so we're going to draw the dipole arrows for those polar bonds. And just a reminder, the arrow points at the more electronegative. So oxygen is more electronegative. So we're going to draw a dipole arrow that points towards that, and same for this bond, okay? Now, I don't need you to do the partial charges, but I do need you to remember where they are, because the arrow points at the more electronegative, and so this is where it's negative. That means like this region, especially with these lone pairs that are electrons, but the oxygen is partially negative because the arrows are pointing towards the oxygen, and the hydrogens are partially positive. So do not forget that whenever we draw a dipole arrow, the arrowhead is showing us where it's negative, partially negative, and the tail is showing where it's partially positive. Okay? Alrighty. Now, observe how the water molecules behave with each other. So now you're back to your model kits. Okay? And you're going to be looking at how these water molecules are interacting, how they are connecting, okay? And here's something I want you to consider. This is a full molecule. These are covalent bonds. So I'm going to draw those ones as solid. And then today, if you notice, because sometimes there will be, sometimes there won't be, if there is attractions between molecules, like this one, I would draw that with a dotted line, a dashed line, not a solid line. Okay, so like just looking at this right here. Here's the water molecule. Okay, there's the water molecule right there. I didn't draw the lone pairs, that's fine. So here's that water molecule. And there is an attraction to this one right here. Okay, so this part of the molecule is attracted to this part of the molecule. So it looks like that there is an attraction between this part of this molecule and that part of that molecule. Okay? And that's what I want you to be doing today whenever you're drawing. A solid line indicates a covalent bond. This is a molecule. If there's a dashed line, that means it's an attraction between molecules, not inside, not within the molecule. Okay? So separate molecule, attraction between the molecules. You need to draw a few more of these. Okay? So like I need to see more on number 3, and then you're going to be answering number 4. Now before I turn this over to everyone, let me explain what else there is in your kit that you need to know about. Okay? So you're going to come back to number 3 and number 4 in just a moment. So sodium and chlorine, a positive cation and a negative anion, and notice that the negative anion is bigger and the smaller one, the cation, is smaller. That's this part of your kit. So the bigger green one, this is the chlorine, and the smaller blue one, that's the sodium. Okay, so when you get to those ones, now you know what they are. Okay. At the front of the room, there's 2 other models, and everyone, there's not enough of these to go in every single kit. So just know that these are going to be at the front of the room. I'll have them labeled for you so you can come and find those, and they're going to be on the front demonstration table. So we got 2 models here. The first one is ethane, okay, ethane. And so it looks like there's 2 carbons, and then there's 3 hydrogens around each carbon. And that's this guy right here. Okay, there's no red in there because remember, red is oxygen. So there's no red atoms in this model. Okay, so it looks like we got 2 carbons and there's the hydrogens around it. So this is the ethane. So when you get to number 8, you're going to come up front, you're going to grab one of these so you can answer all the questions. And then when you get to number 11, you'll take this back and then you'll go and get this guy right here. Okay, so make sure you take this back because we're going to need to use them in different groups. All right, so then we go back and we grab this guy. This one is ethanol. And I can tell that this is the right model because there's that oxygen, and look, here's the oxygen. So let me flip them around. Okay, so there's the oxygen, there's the oxygen. So this is our ethanol. And then you're going to use this model from number 11 through 13, maybe 14, I think 14. Okay, and then you're going to bring this back. Okay. After you've answered all of the questions up through 14, I do want you to do part 3, the conclusion. So you're going to answer these questions based on the activity and then all the way through 20. So page 11. So please, everyone, my expectation of you today is that you're working hard the whole time and that you are finishing pages. Let's see, what one did we start on? Page 7. Okay, so you're starting on page 7, and then you are finishing page 11. I want to see page 11 done. And then once that's done, you're good to read a book, work on other homework, but I do need those pages done because next class, we're going to be diving right into the next activity. We're not going to be going back and working on this anymore. Okay. All right, I appreciate you all so much. Thank you for just being wonderful students. You've got this. Keep up the good work, and then I will see you all next class.